We did it, boys. We did it. Assignment 1 completed. We have slain the first dragon. The proto-drake. Not a full dragon. There will be bigger dragons in the future. But a dragon nonetheless. I've spent the past week and a half chipping away at this assignment. Probably doing an hour or 2 hours a day. And now it's done. Completed. So we've officially built a lexical scanner for the Ada programming language. All tests are passing, all the lights are green, and our scanner is perfectly matching the language spec. So this was a hell of a task, and I learned a lot. I learned how to use the Flex Lexa generator. I learned how to integrate the Google testing library into my program. I learned how to override certain parts of the Google testing library when I needed to. I learned how to use CMake, set up a CMake lists file. I learned a lot about writing regular expressions. And each of these things presented unique challenges along the way. One by one, I took them on, and one by one, I knocked them over. So this is how it works. We start up here with our Flex input file. This file contains regular expressions, rules, and actions that define how a scanner should pass the input files. We then pass that Flex input file to the Flex program, which is a Unix program that takes in these regular expression rules and actions and converts it into a C program. So from Flex we get a lex.yy.c file. We then compile that into a Lexa program. Then our main program, which is called ATAC, which stands for Ada Compiler, reads in the input files, which are of the Ada programming language source file. It then accesses the Lexa program to run the Lex job. It gets the Lex job of the Lex results back. And finally, we output our .lext format file, which contains our output and all tokens. So here is the Flex input file. I wrote all these regular expressions, which can be captured in variables. Then once the Lexa program detects one of these regular expressions, we execute a rule. In this case, we're outputting and formatting to the correct format that we want, but we can also do other things like ignore comments, and we can also increment the row count and the column count on other characters as well. One thing that was particularly challenging in this file was the need to define my own custom functions. So I needed a custom function to remove the quotations or quotation marks from string literals and character literals. And I also needed a custom function to handle Unicode escape sequences according to the Ada specification. So in the Ada specification, only some Unicode escape characters are actually substituted for their real value. Any non-printable or special characters should just remain escaped in the output. So that was particularly challenging. That required me to write custom C functions. I won't bore you with the details, but that was pretty fun. So this file gets fed into the Flex program, and that outputs a Lexa program, which I'll show you now. So the Lexa program does exactly that. It lexes input. So I'm going to give it some input now. We're going to say When I press enter, this program is going to lex this input, and what we should see is this Unicode escape sequence be substituted for its correct value, because this is a printable Unicode character. So we should see a bunch of tokens, and one of those tokens will contain the string literal hello world. So let's do it now. Perfect. So line 1, character 1, we see an ID of X. Character 2, we see a symbol, colon. Character 3, we see the keyword int, and some more symbols, so on and so forth, until line 11 we get to the string literal and then its value of hello world with the Unicode value successfully substituted in. Now we're going to look at the main program, which is called ATAC, stands for Ada Compiler. So I'm going to do some lexing. I'm going to output my resulting files into the build folder, and I'm going to lex this specific file. So this is an Ada program that runs an insertion sort. When I press enter, we should see the file get lexed, and then we should see a write to the output location. Perfect. So we lex the input file and we write the output file. So I can show you both of those. The input file was insertion sort. Looks like this, just a typical Ada program. And then the output file looks like this, a list of tokens, and it matches perfectly to the assignment spec. In fact, all of these files lex perfectly. All of these files in here were given, down here, all of these input files were given by the assignment spec, and I've gotten all of them to work perfectly. So now I'm going to show you the testing function that ATAC has. If I run ATAC with the test flag, we're going to see all of these tests, all of these source files in here get tested against the official solutions, and then hopefully they're all green. Let's go. Perfect. All tests green. We did it, boys. We did it. So, thanks for watching. Stay tuned for the next part of the course, which is syntactic analysis. And yeah, let's keep slaying this dragon.